Good afternoon, ladies and gentlemen, and welcome to today's webinar. My name is L'Oreal Dessart, and I will be your host for the next hour. Today's session, How to Create Smart Cities of the Future with Real-Time Intelligence, will be presented by Mr. Varun Khandelwal, Solutions Architect for Analytics, BCT-TIBCO. As I welcome Varun on board and invite him to kickstart the webinar, let me share a little bit more about your presenter. Mr. Khandelwal is a solutions architect for analytics with BCT-TIBCO and TIBCO, and is a renowned technology evangelist for analytics and data science solutions. Varun enables businesses to remain competitive in the ever-changing digital landscape, empowering accessibility and deep insight into data for critical decision-making and strategic transformation of operations in a highly competitive world. Mr. Khandelwal is a veteran in solving business problems through data science in the banking and financial services industry, energy, media and networks, consumer goods, retail, and telecommunication verticals. Varun, it is our absolute pleasure to have you with us today, and we look forward to your webinar. Before we begin, let me just share some housekeeping before we hand over to our presenter. The webinar will be approximately 45 minutes to 1 hour. If you have any questions, please do not hesitate to type them into the question box in the Zoom control panel. And as your moderator, I'm happy to bring those questions up during our Q&A session, which are hosted at the end of the presentation. I kindly request you all to keep your microphones muted whilst the session is in progress to avoid any background noise or disturbance. Ladies and gentlemen, without further ado, it is now time to garner insight into how to create smart cities of the future with real-time intelligence. Over to you, Varun.
Thank you, L'Oreal. Thanks a lot. Hello, everyone. Welcome to you all. So today we'll discuss on smart cities. And as L'Oreal mentioned, you guys can ask questions as we are speaking, right? Feel free to type them. And if you feel we need more discussion, feel free to speak up and ask your question as well in between. Yeah. So without wasting much time, we'll go directly into the presentation. So just because there would be some people who won't know about TIBCO and BCT-TIBCO, so I'll take a couple of slides just to explain who we are. So TIBCO is a global organization with presence in multiple geographies with 15,000 plus customers, and primarily at TIBCO we do three things, right? Connect, which is basically making sure we are able to connect to any application, device, app, data, right? or even people for that matter, right? So connectivity is key component to do anything. Once you have connectivity in place, the next thing you want to do is make sure that the data you have is in a secured manner, in a governed fashion, so that you are able to make best use of it, right? So that's where the unification comes into picture. And once the unification has happened, you want to make use of that data, right? That's where the value resides in. So you start by building predictive analytics, visualizing the data, or taking actions on the data you are collecting. And then we'll go into detail of this, right? But at heart of everything, TIBCO, what TIBCO does is it has this connected intelligence platform, which has three primary components, which is connect, unify, and predict. Yeah. And as I was saying, so it's a global organization, 15,000 plus customers into a lot of verticals, all big organizations in one way or the another use TIBCO. About us, BCT-TIBCO. So we are again a multi-national company with presence in multiple geographies, 4 continents, 20 plus countries, 3,500 plus associates. We are into providing digital transformation solutions to our customers, presence in multiple geographies again, and again we have our own IP in different areas. So we'll talk about all of these things as we move further in our discussion, right? But this is just overview for all of you. So today, as we are going to discuss around smart city, right? Like just to create like what are we going to spend next 40-45 minutes, right? So basically the idea is what I thought, the way I'll present this session is primarily around talking about obviously smart city at initially very high level. Then we'll go into the technological components in little detail, and then we'll talk about different areas of smart cities where we see those technologies being applied, right? And one interesting thing about smart city is it's a pretty broad topic, so it covers a lot of things, and it means a lot of things to different people, right? And as I speak, I'll try to cover those different angles of how you look into a particular smart city. But one thing I have realized over the period of time, by obviously talking to multiple people who are doing this, by doing this my own self, right, and then by listening to others in the field as well, is it's a pretty broad topic. There are a lot of things going on in specific pockets, and it's like, if one thing I always recommend my customers and everyone who is in this field is not to go big bang, or not to think of a big bang in terms of smart cities or solutions around smart cities. And when I say big bang, it really means like you are not going to don't start imagining the complete the sci-fi things which you can imagine, but go small, because that's where the value resides. And once all small pieces are ready, things will automatically fit into the complete picture of the big picture, right? And that's where the interesting part is coming into play. And that's where I feel, and a lot of the others whom I especially hear and read, right, they strongly believe that it's not about solving the complete problem, but about solving many small problems to create a bigger solution for a bigger problem, is something what smart city is all about. So now going directly into the thing, right? So obviously when we talk about smart cities, as I was saying, right, so there are many things around it, and we can, so this is like specifically a slide from IDC. So if you look into a thing, right, there are always assets, and these assets are present in context of government infrastructure or even private infrastructure for that matter, right? So you have assets. Those assets can be like purely dumb asset, or they can be more smart by basically enabling them with more sensors and collecting data continuously from there. So that's where an asset is converted to more of a smart asset. Once you have a smart asset and you are collecting the data, you might want to connect it, and basically make it a connected smart asset, right? Not just only a smart asset, but a connected asset where you can control things on asset. And this asset can be anything, right? Obviously I've shown vehicle, but it can be anything for a matter of fact. Once you have the connected asset, you want to build the connected asset. So that's what I was saying, the small component. So first, if your assets are not connected or not smart to start with, right, you can't even reach the stage of being connected systems, where you have multiple assets or multiple systems which are connected in a way and talking to each other, right? And this when you take it into a broader sense, right, of systems, and that's where again I was going, right, that you start small, maybe each specific use case you try to handle, and eventually what you will build is, over the period of time, by connecting the dots, you'll build a bigger solution around the smart systems of systems, which are one system is able to communicate to other in multiple different ways, right? For example, if there is an incident happening in one part of the city, then the respective authorities are being notified intelligently, and the action is being taken place in a very faster speed, right? So that's where you talk about systems of systems and connecting them, and basically taking more automated or more intelligent decisions on the real time data you are collecting from those assets or systems. So that's again a very high level, and again we'll start to go more detail into each of these components. Yeah. So again, obviously, at here with TIBCO, we solve most complex data and system problems, right? So you can imagine these problems are not easy, even though you can we think them to be easy, but world tend to think them actually complex. So it's actually a dual nature in itself, right? The way you solve things make your problem an easy or a complex problem, but we have habit of solving these complex kind of problems in much easier manner, right? And again, to solve this, we always believe that there are three primary technological component which are needed to solve any kind of a digital problem these days, right? So one is obviously connectivity. And again, when you are talking about connecting to your asset, to your systems, or even systems talking to each other, these are all connectivity piece. So connect is not necessarily one part, but think of it in a broader sense, where you are able to connect to your assets, your equipment, your devices, your people within system, talking to each other, right? That's where the connectivity plays a very important role. And once you have the connectivity in place, you basically are getting a lot of data, right? So you need to basically make sure that that data is unified, that data is secured, that data is governed, so that there is no risk with the data you are collecting. And once the unification has happened, obviously you want to use that data to visualize important KPIs, to do predictive analytics, to basically take actions in real time as you are gathering the data. So that's the predict and the third part of it. So that's where basically we go from connectivity, connecting to anything, be it your IoT devices, be it your applications, be it your data systems. So you can connect to anything. Once you have connected data from multiple places, you want to make sure that it's secure. Only people who are supposed to access it are able to access it, and access it in a much easier way, right? And again, when we talk about unification, and I have a slide where we'll talk about how application to application data interaction can also happen with the unified layer on top of it, which is again very interesting. And obviously the predict part is where you start getting the value out of your effort which you are putting in. So this is again in very short, TIBCO connected intelligence is nothing but three primary component: connect, unify, and predict. So now we'll try to merge the technology and the use case, right? Because we see a lot of things happening around smart cities, and if we break down, again, this is from IDC, right? If you try to basically break down smart city use case into different component, you will basically be able to break them into this five layer. So one is economic development and civic engagement. So there are a lot of different initiatives under this, and then we'll talk about it in detail. But at a broad level, you can classify them as economic development and civic engagement. Urban planning and administration. This is again very useful, very much needed for any city to be um, serving its people, right? Very important part. Data driven public safety. So using data for a lot of public safety, we see a lot of government organization, a lot of private organizations doing this, starting to make intelligent use of their data to basically drive public safety. And especially in COVID times, even public or even private sectors companies, right, basically are trying to gather data around their employees to ensure safety and ensure the well-being of their employees. Again, one big part of the city is its energy and infrastructure. So basically making sure they are smart, they are able to communicate, they are efficiently using the energy, or they are efficiently being used in the sense that the overall cost to the uh, to to uh, to its citizens is minimized. And lastly, it's all about intelligent transportation, because that's where a lot of the thing goes into when we talk about cities, right? So transportation is one big, and when we talk about transportation, it's pretty broad in its own sense. So be it vehicles, be it public transport, be it trains, be it flights, and others, right? So when you talk about transportation, it's again a broad thing. So as smart city, we can basically break down things into this component, and then we'll go into uh, uh, in different areas of this component. And again, as I said, smart city is a pretty broad thing, right? So we'll try to focus on the component where we can use more of a technology, especially the technology what I'm talking about, right? Primarily around IoT, primarily around streaming data, predictive analytics, visual analytics, data management, and so on, right? So we'll focus on those areas. And at TIBCO, obviously, there are a lot many things we can do, and as I was saying, we'll go into some of those pieces as we go through more slides. So at the heart of all of those high level use case, right, one thing and one theme that you will see is there are four things again which are happening. So one is basically the data. So the ability to connect to the data, to manipulate data, to wrangle data, and to make that to get insights from that data is something which is very important, right? So the first step is data. Deriving insights from it is obviously the next step. And once you have derived the insights, you want to basically take actions, and those actions you basically want to take in more real time sense, so that as soon as something is happening, you are able to act on it. And once you are able to act, as you are acting, you should be in a continuous learning mode, wherein you are just not uh, like making or taking a dumb decision or rules based decisions, right? More much, but rather more intelligent one, which is more data based, where the data itself, where the models are being built, which learns from your data. And once that data is changing, your models are changing, and it's able to adapt to the changing scenario in a more intuitive manner, right? And that's where the circle completes with the learning in a continuous manner. So that's where the data, insights, action, and learning are the four key pillars. And the reason I'm talking about these pillars is because we'll see when we talk about different use case, right? You will see how these pillars are used to basically solve these problems. Yeah. Mm, uh, and again, so next few slides, basically, I'll try to cover more technical components which are used for smart city solutions, and then we'll go to the specific use cases, so that we are able to tie the technology with the use cases, right? And this is coming from Gartner, where they have built this end-to-end thing architecture, right? Where they talk about this edge tier, which is nothing but the layer where your devices reside, where your equipment resides, where you are basically getting the data from, right? So that's where the edge tier is. And again, as I said, so devices, applications, appliances, sensors is all the data you are getting from the edge tier. Once you are collecting that data, there are a lot of things you can do, right? So you talk about uh, edge analytics, which is primarily taking actions on the data at edge. So this is again very smart way of doing things, where you don't push every data you are collecting to cloud, but rather take actions on the edge layer itself, right? And once you have the data, obviously you have to push some of the data to your enterprise layer, be it cloud, be it on prem. And as you are moving this data, these you need different capabilities of analytics, where you are gathering the data, where you are collecting the data in a very streaming in a fast manner, and basically taking actions on top of it, right? So that's where the stream processing comes into picture. As you are getting the real-time data, you want to basically uh, know what that data is and take appropriate action for that data. And from that platform layer, you basically start to move more enterprise application layer, right? Where you have collected the data, and then you want to interact with your enterprise applications in place to make decisions or to build data analytics, right? KPI based dashboards, where you can actually monitor and see things around what is happening in and around your ecosystem. So that's the three layered architecture of edge, platform, and enterprise. And again, we'll go into important component of this before going to the use cases. So one of the things that is obviously, now by now you might have realized, one of the key and important thing in the entire smart city ecosystem is applying analytics in real time as you are getting the data, right? And also collecting that data in real time is obviously the part of it, right? So you have basically the data coming from multiple places, and again, this data can be the transactions, the weather, because you might have in public transport, you might collect transaction data of who is traveling where. You might have the weather data, you might have location data, GPS data, and you might have data coming from your devices, right? Equipment, a lot of heavy equipments being deployed either by a government or by private sector, actually generate a lot of IoT data coming from maybe SCADA-like devices, right? And then you can basically connect to those IoT data or fast-moving data, um, and that's where the connectivity to any kind of streams come into picture, right? So at TIBCO, we provide this capability wherein you can we allow you to connect to any kind of streaming or moving data, right? So that's where connecting to any stream comes into picture. So basically, once you have the capability to connect to any kind of data within your ecosystems, and you are basically making them more smart, right? By collecting that data and acting on top of it. So that's where we provide you the capability to connect to all of this kind of data. Once you have the data, obviously you can do transformation, aggregations, and you can apply data science on top of it, right? Or if you want to start slow, you can basically apply rules, decision tables, or simple rules on top of it, right? For example, if you have like a public transport, right, and you want to intelligently decide what should be, if there are no people on the route, whether we should stop or make a stop or not, right? And if basically two trains are moving like because of the delay or anything, right? They are very close to each other, and to manage the crowd within those two public transport places, you want to make intelligent decisions in real time, right? So that's where you can apply simple rules, or you can take your models, and those models are nothing but, it can be any model, right? It can be Python, R, TensorFlow, or and from many other ecosystems, right? PMML, Java, and how do you build that models is another part, right? So that's where the data science come into picture. But once you have the model, you can basically deploy it into something called as TIBCO model ops, and through that model ops, you can basically do the scoring or the inferencing of the models which you have built. So that was completely the streaming analytics piece, right? And as output of it, what you get is something we call it as digital twins. And what is digital twins? Let's spend like a minute on it, right? If you talk about collecting the data from your assets, right, be it vehicle, be it the traffic signal data, or be it your public transport data, right? As you are getting the data, you are basically modeling that physical asset into its digital nature, right? So if you have like a signal, and it has been on and off, and you are basically trying to collect how many vehicles are there on that signal, what you are basically doing is you are creating a digital environment of your physical world. So that's what is the digital twin. And because we are able to collect this data from different sources, do transformation, aggregation, and different kind of processing on that data, and even apply intelligence, you can actually visualize your physical asset in a more digital way, and do basically the remote monitoring, right? You can be in a remote place, monitor that equipment, device, or a particular scenario, and have a digital twin of that particular piece, right? So you build those streaming visualization which keeps on changing as the incidents are happening, and as incidents or events are happening, and if any analytics has applied, you can even see that being applied in your digital twin console kind of a thing, right? Obviously, as some event happens, you don't just want to visualize that, right? You want to take some actions also. So that's where the automated actions comes into picture, where based on the different scenarios, actions will be automatically triggered and can be configured to basically call your third party system also, right? So it's not always about doing the complete thing by ourselves, but we understand that there might be an asset management systems, or there might be a customer experience management systems, where we just want to push the events and make sure that someone is acting on those those events and take actions on it. And obviously generating the alerts, right? If there is some alert that needs to be generated, especially like for cases where you are actually transporting a lot of like where governments or banks are transferring money through a particular routes, right? And then if they are going to a high risk area, then maybe some alert can be generated based on location based analytics also, right? So there can be different scenarios and different alerts can be generated based on the event itself. So as an output of it, you can basically visualize your physical things into in a more digital manner. You can take automated actions and you can generate alerts as things are happening. And when we talk about this data which is getting generated in real time, you are basically building that entire infrastructure. What you also want to do is you want to persist this data as you are capturing it, because that is the data you might use while you are building your analytics, or while you are building your KPIs or your reports, right? And for that, you basically need to modernize your data architecture by making sure that you are able to get the IoT data, you are able to get your big data, you are able to get data even from your data warehouses, files, different master or reference data, or from your database management systems, and basically build this logical layer where you are able to provide a unified view to your business intelligence applications, your analytical applications, your data science applications, and in general get a 360-degree view on your data set, right? So this is again the second important piece where after collecting the data, you want to make sure that that data is placed and used in a proper manner. Obviously, when you have this huge data, right? For example, you might have the traffic data for last 5 years. You might have the data from your equipment for last or from your grid data from last several years. You want to basically take that data and apply some intelligence on top of it. And how you can apply that intelligence is through something like TIBCO data science, where we provide you the capability to again connect to the data, access the data, build predictive models on top of it. So it's a drag and drop based tool wherein you can build your predictive models. So for example, if you want to do more of predictive maintenance of an asset, right? Or if you want to build more intelligent traffic management system. So as how do you decide basically when the signal should switch based on what kind of conditions, right? So either you can make it more hard coded or rule based, or you can make it smart in terms of using the historical data and building models on top of it so that they are more smart in driving values from the historical data itself, right? And once you have the models, you want to make sure that you operationalize the model. And for us, operationalizing model is nothing but the model ops which I was talking about. So basically the model which is built in data science get pushed into our model ops, and then it's basically being used within the streaming ecosystem to do the inferencing or the scoring of the model. When we talk about data science, I won't go again very detail into all of these things. If you have any questions, we can have more detailed sessions on this kind of things. But the idea is to give you the high level concept so that we can talk about more use cases and how these are used primarily. So the next is obviously the data science, where we talk about you have the historical data, you want to build the models, we provide the drag and drop capabilities, and it has a lot of good capabilities with integration with Python, R, and even for in database computations, right? So it's a one of the best tool out there in market. If you see, we are leader in Gartner quadrant for data science and machine learning platform, very strong with our offering around data science. Obviously, once you have built those data science models and you have the capability to take the data in real time and take actions on it using the models you have built, at the end of the day, we were talking about visualizing, right? You want to build those digital twins. So there are different ways in which you can build it, and one of the ways we provide is again through our visualization engine, where you can use this same visualization engine for basically building your KPIs dashboard and reporting. So your traditional BI things, it's all self-service. It's very powerful BI tool wherein you can drag and drop and build things. But you can also use the streaming data to build your streaming applications, or as you can say, the more of a digital twin on your physical asset, right? So as you are getting the real time data, you are basically making things move in real time as things are happening. So again, a very powerful way of looking at the visualization, and again, we have very strong offering in this entire area as well. And again, we are leader in BI space, and we are I think only one vendor who can do both the data on rest as well as the data on motion, right? So it's pretty strong offering again. So now we'll go to different use cases around this different areas we talked about, right? So the economic development and civic engagement, urban planning, data-driven public safety, energy and infrastructure, and intelligent transportation. And we'll see how these technology components are basically used in this individual places, right? So we'll talk about first the economic development and civic engagement, right? When we think about civic engagement, it's very important to think around we are basically utilizing the data which is being getting generated through public lives, and basically doing monitoring on top of it, and basically sharing that data. So as a government institution, I should always be collecting these kind of data and sharing it in such a way that it creates a more open environment to be used in a much public uh, in a much public manner, so that it can be used for the good of the people, right? So that's where we start with, right? And we see a lot of the things happening around a lot of the things we are doing around is to take the data from COVID, and basically do this key metric monitoring in the single place, right? And as the data is coming in, though, you can see the data being visualized, you can see important statistics, you can see important KPIs, and this kind of data is really helpful for government and for government institutions to basically make decisions, right? So whether should we open up, how much should we open up, what is the rate of increase, what is the reproduction rates. So all of those information basically helps uh, by letting government do non-pharmaceutical intervention, so that they are able to take things under control, right? So and it's been heavily used by a lot of organizations. It's a very good way of basically visualizing the public health data in current context. And when we talk about this in a more broader sense, right? So there are a lot of organizations doing different things. There's a disaster recovery, disaster management, or entities. There are entities who manage the food quality, food safety, and other things, right? So basically taking that data from multiple places, visualizing them in a very easier manner, and making it available to authorities, so that basically they can act on that kind of data, right? And even build more of a forecasting model for the kind of diseases that might happen in a particular area, is something very interesting. And again, if you see over here, the idea is to basically collect the data from multiple places, which we obviously support. Once you have the data collected, you want to visualize the important KPIs, and highlight the anomalies, or any kind of problems that might be happening in different areas. So it's again very you use the same technological component basically to solve this problem, as well as the COVID problem, right? Again, the COVID data coming from multiple hospitals needs to be aggregated, multiple institutions, there are multiple kind of data coming in, right? What is even sometime getting the readmission rates or reinfection rates, and modeling that component together with your traditional data is something very useful for a lot of government entities. Again, if we talk about more in terms of the services being provided to the citizens, right? In terms of especially electricity, or if there is any fault, or if there is any issue going on, right? You want to monitor what is the basically the service time, the fault restoration time, and so on. So you can do key metric monitoring, and based on those monitorings, basically you can decide which organization is working more efficiently and not. And especially in UAE, we are seeing a lot of these things, and many other governments out there, right, who want to basically utilize this data to actually provide metrics around the service and the quality that different department is providing to their citizens, and that's where again a very important area of using data to basically make more smart and intelligent decisions. Again, another angle of it is looking into uh, uh, the police, right, and the security basically of the citizens by basically collecting the data of uh, incidents happening, right, maybe in real time, maybe in an historical fashion, trying to analyze which area is giving more problem, where which city administration needs more help or more intervention in terms of helping them solve the bigger problem, right? And then you can basically do this performance of your people, of your assets, or of your event, right, based on the data you are collecting. So again, very important place where lot of the smart data is needed to basically make decisions. And to the underlying of all of this is basically the idea of open data and data sharing. And a lot of the, as I was saying, right, so a lot of the governments, a lot of institutions basically wants to expose a lot of the data they are collecting, so that you can basically use that data to make intelligent decisions. Especially these days, I see a lot of data coming from the rentals data, or different areas, right? You see different maybe price index, or kind of the quality index on different data, and then you can your public in general of that particular area can make decision using that data. And one of the important aspects of making this data available to public is to make sure that it's securely and made available in a more API led fashion, right? And the thing I was telling about the data management or the data virtualization piece, right, where you can get the data from multiple places, and if you want, you can create an API layer on top of it, so that you can easily share the data with multiple organization, multiple institutions. So that's a very important aspect as well of collecting this data and sharing that data in another more seamless manner. Yeah. The next we'll talk about urban planning and administration. So this is again very important aspect where we see a lot of data driven planning, digital twin, the smart city platform in itself, uh, right? So data driven planning is again very important, wherein a lot of organization, and this again is not only up to the public sector, it's also on private sector to use basically the data to make more informed decisions, right? So basically one of our customers uses wind power provider. They use the data from multiple places, multiple location, to make more intelligent decisions or more planning decisions, right, where to deploy things, where the market needs will be there, and based on that you basically try to minimize your cost and serve your end society in a much better way. So that's about data driven planning. uh, Again, this is not only about, as I said, right, so obviously government institutions are one, but airports are part of a bigger ecosystem where we all interact with, and having this capability of basically creating those digital twin out of the data which you are getting from a lot of the assets, be it your passenger data, be it your baggage data, be it your entire parking data, right? Collecting that and making it available in a way that you are able to make more easy decisions or more intelligent decision that drive actually the revenue for the airports, plus provide a better customer service uh, to to the end user, right? Is something which is very important. And again, it's very important for urban planning and administration, as we see. Another very interesting area, and this is primarily I'm talking because we work with Formula One, Mercedes, AMG, Petronas very closely to basically uh, drive digital twins of their cars, so that they are able to analyze the car data in much more detail and take more intelligent decisions, right? Though it's not again related to public or like urban planning, but it's very relevant in a very equivalent sense, where you take the data from maybe your public transport, maybe your like trains running, right? Or maybe your traffic data, and try to map it in such a way and make intelligent decisions in real time as things are happening. So it's again a very classical case where we are connecting the data from uh, um, the race plots, taking the data and basically visualizing and acting on it as we are getting the data in real time. And just to give you a small demo, right? Again, most of these demos are whatever I'll show are available in public on Google, so you can even search and look into more details. Or if you have any questions, you can ask us, and we'll be happy to have more detailed sessions on it. So basically, if you see, this is where the race track is, and basically if you want to, so this is where how strong our visualization is, where you can actually not just visualize important KPIs which you are doing, but also visualizing it in a more geoanalytical fashion, and where you can see the different colors, right? The different colors are nothing but they are representing how the car is being driven in that particular path, where the things are looking good, where the things are not looking good, and if there are curves, how things are moving, right? And you can use that historical data to basically build different kind of models, which will tell you if you drive in a particular fashion, or if things are being happening in a particular fashion, what will be the output of it, right? And that's where you can build different models. And this is our data science platform, where you can build different kind of workflows. You can basically do feature engineering, you can basically do your model building, and once you build those different models, you can apply those models in real time to make decisions as you are getting the real time data from maybe car, or maybe from your public transport data, right? So again, very important and very interesting way in which we can use data to make things more intelligent around you. The next is data driven public safety. So again, this is very important piece where a lot of the visual surveillance, a lot of the crime data, crowd monitoring, incident response. If there is some incident, how are you responding to it, and so on. So again, a lot of government agencies are interested in solving these problems, and it's key problems for a lot of the organizations for better customer service. So again, to do that in a broader sense, a very important aspect again is around data sharing, because once the data is shared, it can be used by public in general, or other entities, or even government entities to do analysis on top of it. And again, you can build early warning systems, a disaster recovery system. So based on the data which is being generated, maybe from the devices, maybe the traffic data, maybe the weather data, maybe especially in times of calamities, right? You're getting a lot of data in real time, and then you are taking that data in real time to make decisions uh, for disaster warnings and recovery. It's something which is very important, and the way you do it is something which will differentiate you from the rest of the world in serving your society. So again, the idea is very simple. You collect the lot of the streaming data based on the data you are more interested in, especially around disaster management. Once you have those data, you want to basically visualize them. You have models, and you want to basically use those models to take actions in real time as you are getting the data. Actually, I'm like, we don't have much time, so I have more content, so that's why I'll try to be more little quick in terms of use cases, so that I can give you a high level view. And if you are again interested in specific thing, we can discuss in detail as well. So the next is again crowd monitoring and mob management, and again this is very important, especially in cities where it's important to control the crowd in a particular area. And this same thing can be applied in maybe a mall, or maybe in a theme park, or maybe in the airport, to basically monitor the crowd and manage the people around it, right? So again, we there is a small demo which basically shows how you can basically take the data in real time. So first, basically you do the configurations, and once you have the configuration, you can basically say that you want to monitor this particular area, and based on the historical data, you can do the analysis that this area, how much people should ideally be there, and based on different events happening in a particular location, or even what are the conditions in this particular area, you can basically build that model and deploy it for real-time analysis. And once that data is put into the real-time analysis, as you will get the real-time data, it will basically monitor it and highlight if there is some mob building happening, or more people are gathering in a particular place than expected, right? So it's a very classical use case. Lot of governments actually have done it. We have worked with multiple organizations across the world for this kind of solutions. Very useful for governments. Again, as I was saying, so it's not only about monitoring the people on road, which you normally won't do unless it's a critical place, or you want to monitor a specific area, but you can extend it more in area of airports, or your malls, or your theme parks, or your public gardens, and so on, right? And especially in times of COVID, it's again very useful, again in this context, just to make sure that the place is not getting crowded. Governments are working to basically have this kind of place where they monitor a lot of people in a place, and then raise alarms or take actions as those events are happening. As I was saying, right, so you try to become more advanced in terms of using only the sensor data, and basically add more of the visual data. So these days, because of visual the image analytics, I'll say, you can collect the video data, you can apply algorithms on top of it, and take actions on top of it, right? So that's where the visual surveillance comes into picture. And again, it's a very one of the things within TIBCO that was done was around the monitoring of a particular place, right? So as cars are moving, you can basically monitor the cars, and as things are happening, you can see things are changing in real time, and you are able to see what is the average speed, what car it is, what time it was there, and so on, right? So you can actually do the analysis on a particular area. And again, this can be in multiple countries. You can basically do, yeah, so you can basically do analysis in multiple sense, and this can be applied into multiple use cases, right? Be it parking management, be it the area management, be it monitoring the vehicles for maybe speeding or for any issues, and so on, right? So there are again various ways in which you can use this, but the idea is again to collect the live data in real time, apply analytics on it as you are collecting the data, and monitoring everything in real time, and taking actions in real time. Again, the similar technological components used to solve a very similar problem. Yeah. So the next is around the energy and infrastructure. So obviously we talked about the other component, but one of the important component is obviously around energy and infrastructure. So if we talk about smart grid, or getting the data from grid, making sure that they are not failing apart, or if there are any issues, you basically monitor them. So again, various again, depending on the country you are in, it can be more private player or more government institutions who want to monitor their assets, right? Even for that matter, street lights, or even for that matter, the grids, right? They want to monitor those grids and make sure that everything is in place, everything is proper, and working as expected. And even if not expected, it shows notification to people out there. And again, for solving this kind of problem, we have something called as IoT accelerators. So what we at TIBCO we do is we build these accelerators, which can basically take the technological components, and we add a layer of business on top of it to create this accelerator, which can be used by our customer as a starting point to build their solutions, right? So as a government institution, if you want to basically monitor or build a digital twin of your asset, you can basically use this accelerator connected to your systems and start gathering the data. And as you are gathering the data, you can visualize it, apply analytics, do KPIs, all of these things in real time. And again, this can be extended further for more use cases, for predictive maintenance and other things. And something good about these accelerators are like they are free of cost on top of our products. So you really don't have to pay anything extra for it. You can, and we have customers who have used this accelerator and seen the benefit of it, and basically able to deploy things in production in like 4-6 weeks kind of a time, right? So it's very powerful in that sense. Again, I'll try to move little fast in interest of time. So the next is again intelligent transportation. Transportation again is interesting area of getting the IoT data acting on it. So again, you can start by smart public transportation. So you basically, if you want to monitor the buses and if they are public transport moving in a particular fashion, right? And if they are too close, you might want to skip a stop, or if there are more people in a bus and you need more extra service in a particular route based on the crowd, you can basically do dynamic changes, right? So again, it shows a very similar thing. Traffic management, again, very interesting area where you can use the traffic data, and if there is you can basically manage your signals. Plus you can actually, if there are any incidents happening, you can use the sensor data, or even for that matter visual data, right? And if there is any accident that has happened, it should automatically trigger an incident thing in your police department, so that they can act on it, or the traffic department, so that they can act on it very fast, right? Rather than someone calling them and they coming in. It's basically important to basically uh, make sure that you are able to monitor it in real time and act on it in as fast as possible, because that in such cases it's a matter of life and death, right? So smart traffic management plus incident management is very interesting use case. Parking again, right? Because public parking is one of the challenging areas. So providing that information in a very digital manner, doing the forecasting or trying to understand where more parking is required based on the demand, and basically making that data available in real time, so that when I'm searching for a parking, I should be able to find the available parking in the most faster manner, right? So is some of the things that will make life of people of the city obviously very easy. And again, not just in a public parking, but when you are going to maybe a stadium, or maybe airport, right? You want to basically make sure that the planning is being done using the historical data of uh, when and how the parking is happening, and using that data to basically take the future decisions on how the parking should be done, or maybe should we increase the parking price in a particular place so that people don't bring much of their car, and so on, right? So those kind of decisions needs to be done based on the data you are collecting. Journey planning, again, as I was saying, right? So it's part of one of the earlier thing which I was showing, but on a similar line, right? Once you have the journey data coming in, you can actually make if you want to analyze what routes your public transport should work on, so you can basically see where you are getting more people, and okay, can we switch some of these area to make it much more intelligent in my route planning, right? So it's very important aspect using the historical data to basically make future decision is something very important in such cases as well. Again, this is not limited to, obviously these are the primary purpose for governments would be around public transport, around traffic management, but it can be further extended to smart ports and smart airports in a very similar manner. And again, we are doing equal amount of work with private sector as we are doing with governments. So for this, again, what we have done is we have built something called as connected vehicle accelerator. And connected vehicle accelerator is nothing but a layer on top of our products, and again, it can connect to any kind of vehicles, be it trains, be it bus, be it flights, and be it like cargo vehicles, right? You can basically take them, you can see the plan for it, you can do real-time monitoring, you can take real-time actions, and it's one of the very popular accelerator we have at TIBCO. And again, we have seen a lot of government institutions, a lot of city administration, a lot of private sectors, including the likes of airports, have used it and benefited from it in significant manner. Yeah, so as I was saying, so obviously you can apply it for public transportation, railways, metros, tram, boats, buses, taxis. Again, for airplanes, airport, logistics, shipping, vehicle, just for your vehicles, and the hospitals, and for your money movement, vehicles, security cards, and so on. Right, very very important use cases. So I'll like to wrap most of the things here by pointing out that obviously, as you have seen, this different areas where smart cities fit into picture, right, and where you can basically use technology to solve many of these problems. But the important aspect is obviously around connectivity, around unify, where you talk about the data management, where you talk about different kind of data points, and then basically apply predictive analytics, be it visual, be it data science, or be it streaming analytics in real time, and building your applications in an end-to-end fashion, right? So that's what the beauty about TIBCO is. You use the same platform and you can build technically anything. And the good part of it is all of this is a drag and drop tools, so you don't really have to invest a lot of time in doing the code, and the time to market is very fast. So we have customers who are deploying multiple use cases on top of our platform, enterprise wide or government wide, and getting benefit of it. So it's again very powerful, very useful for a lot of our customers. So next I'll open up for question answer. So L'Oreal, I think I'm done for now, and based on the questions we can discuss.
Thank you very much, Varun. This has been very informative. And I do believe that in a post-pandemic world, the TIBCO Smart City solution is a very critical solution. So thank you for sharing quite a bit of insight. I know that there is a lot more to discuss around this topic. And for all our attendees that have joined, I do recommend that if you have any more questions that really do need to be answered in a lot more detail, please do not hesitate to contact Varun on his email, which is accessible on the screen right now. In the interim, ladies and gentlemen, we do have a couple of minutes remaining. So I invite you to type in any additional questions other than those that we've already received. So please do send them in the question box or the chat box in the Zoom panel, and I will ask Varun the questions on your behalf. Varun, just to start off with, we do have a couple of questions from the audience. The one that has come through first and foremost is, do you have any use cases in oil and gas industry? And can you explain how the smart cities, the smart city solution solves these challenges in oil and gas?
Yeah, very, very interesting question. Again, right, because as I was saying, private institutions have, or even for that matter, oil and gas, big oil and gas companies are government institutions. They have a lot of data coming from the heavy equipment they deploy on field to collect or to produce oil and gas, right? So we have something very specific in oil and gas for like something like drilling accelerator, which can be plugged to your drilling assets, and you can get the data in real time from your drilling assets. Or if more more so in a production, so when your wells are in production mode, you can basically get the data from your producing wells in real time and do monitoring of how your machines or equipment are behaving, what you are getting out of the wells, and so on, right? So it's really a lot of different use cases within oil and gas, even for that matter the supply chain, right? The entire downstream or the midstream of oil and gas, where you track the entire supply chain in an end-to-end fashion, from sourcing to making sure that the goods are being consumed by your consumer and the way they are being consumed. So it's pretty broad and used very heavily.
Excellent, thank you. The next question, Varun, is what kind of TIBCO Smart City solution have you already deployed?
Very, very interesting question. I think so. We have been working with a lot of. I can't answer this like in a public forum like this, but obviously we are working with a lot of government organizations across the world. Some of the names you might have seen here, with city administrations, even within public sector, who are doing a lot of things for the good of the society, right? We work with a lot of those organizations to build solutions, which I have talked about. So be it in traffic, be it in grid, be it in public transportation, to monitor vehicles, to make intelligent decisions of where the parking should be, or for that matter, where what is the optimum route for the public transport to be taken, and so on. Yeah.
Thank you. How difficult is it to build predictive models?
Okay, very, very. So it depends. It depends on how good your data is, how good your historical data is, and so in some cases, because it's more standard, you have the ready data available on historical data. But if not, you basically need to deploy more sensors and get those data and collect it over the period of time, so that you can build predictive models. And one of the important piece of building predictive model obviously is how good your data is, how what variety of data is available to you, so that you can make that decision. So yeah, it depends. Yeah.
Excellent, thank you. The next two questions that I have are coming from two different people. It is related to obviously the current situation that we're all facing as organizations across the globe in the COVID-19 situation. So the first question comes in that says, in a post-pandemic business world, what features of TIBCO Smart City Solutions helps organizations to continue business in a COVID environment? And do you have an example to share other than government or the health sector?
Yeah, very, very good question. So actually, there would be a webinar, or I think there has been a webinar on our Smart Works 360 platform, which is actually built. Some of the pieces of TIBCO are used to basically build it, and what it does is, again, it uses the real time data, and real time data in two sense. Getting the feedback from the people, and the people location data or employee location data. So be it in mall, if you want to monitor the people movement within a mall, or be it in you want to basically manage the request of the people who wants to visit government institutions, so that they don't overcrowd a particular place, or you want to do the mob management, right? Just monitoring the mob out there. So a lot of the pieces actually are very same what we done in the smart cities, and actually we have a very tailor made kind of a thing, which is SmartWorks 360, and we would be actually happy to give you more details around it, which is exactly like a smart COVID solution, but based on the smart city, to get intelligently a lot of the sensor data, even the temperature reading, we integrated with a lot of the devices to basically get the data automatically and take actions on it.
Fantastic, thank you. The next question I am going to ask, what you've just answered now does touch on quite a bit of answering the next question. However, if you can add any more detail to this, then please do go ahead. The next question is crowd monitoring and mob management you spoke about in your presentation. Can this be used in monitoring and crowd control in manufacturing facilities as a social distancing solution? And what data can it provide to ensure HSE and people management within new government regulations?
Very, very interesting question. So again, like SmartWorks 360 is doing this in many ways, and what we are doing is, again, be it factory floor or be it office space, right? If you want to monitor and if you want to ensure compliance, right, we generate compliance report as well based on how many people have been coming in a particular space, in a particular department, and even monitoring the people in real time, and also the temperature, and you can collect feedback from them, right, based on how they are feeling in their workspace, and so on. So especially in manufacturing, because it's an important area, things needs to be working, but you also need to make sure that as incidents are happening, you want to basically act on it faster, right? So as soon as we have integration with organizations like DHA, where if some person is found COVID positive, we can actually automatically know and take more actions on it, so that the people who are nearby to it are less affected. So there are different ways in which you do this, and especially for manufacturing, we are working with organizations to actually do very, very similar things you have asked.
Fantastic, thank you. And before I ask the final questions because that's all we have time remaining for. I also just wanted our audience that are on this call today to understand that these types of solutions, and especially the SmartWorks 360, is actually very tailored and adaptable to any specific industry. So it has been specifically designed to manage the new HSE regulations and obviously the new work protocols that you would require in managing not only, the COVID status of employees, but including any other visitors, be it your customers, your partners, other vendors that are working very closely with you in your organization to obviously continue business as usual. So in our target audience that we have on board today, I see there are a number of you from different industries. If you want any further detail on this, again, please don't hesitate to reach out to Varun, and we are happy to set up a one-on-one call to discuss, what challenges you're facing and how we can help you with this latest solution as part of our smart city solution. Varun, the last two questions I have here is, how long does it take to build such solutions?
Very, very interesting question again. So as we said, right, the reason I wanted to talk about accelerators in my slide is primarily to give you confidence that the solutions can be built very fast. So we have seen and as I said, right, you have to start small and then make it a bigger proposition. So we have customers where we have deployed things in production in less than 6 weeks or 8 weeks kind of a time, right? So that is as soon as you can expect something to go live in production. But obviously it depends in your scenario, in your use case, and what you really want to do. But because this is all drag and drop, it's all connectivity is in place. It's just a matter of bringing this into your environment and getting started in a matter of weeks.
Fantastic. And then the last question I have from our audience: what kind of skill set is needed for building smart city solutions?
Very, very good question again. So there are again different personas, and I actually wanted to talk about different personas, but it was already going too long. So I thought it might not be a good idea to add it in this session. But there are different personas. There are people who are experts in more connectivity and getting the data from systems. And then there are people who are more expert in data engineering or data analytics, who can basically take that data, build models, understand the data, wrangle the data, transform the data, and so on. And then there are more operational people who basically take that intelligence which are being built using the data and then using it in your existing system or building new systems around it, right? So those are mostly your DevOps people or people who are into building applications for your organization. So there are different personas, and based on your need and the skills you have, we can either complement it or you can we can help you hire similar kind of people who can help you in this kind of a journey.
Thank you very much. It looks like that's all we have time for today. So Varun, is there anything else you wanted to mention in closing before I wrap up?
No, I think thanks everyone for joining and for your time. And as we said, like, if you have any question, we will be more than happy to answer it and discuss it.
Excellent. Thank you. Ladies and gentlemen, we've come to the end of our session today. Thank you for joining the Bahwan Cybertech TIBCO webinar, and we look forward to sharing a number of very relevant and transformative topics with you in our upcoming webinar series throughout July, August, and September. As Varun mentioned, we do have a number of webinars that go down with regards to smart cities into various verticals. So we will keep you posted on those that are very specific to you, as well as for our DT SmartWorks 360 solution, which is very relevant in a post-pandemic world. We will be sharing the recording of the session with you, and we'll also be sending you a short survey on this webinar. Please do fill it in and let us know your thoughts on today's session with Mr. Varun Khandelwal. Once again, thank you to our presenter and to each and every one of you. Until next time, stay safe and stay well. Have a great afternoon.